Hello everybody. Today we're going to study a new subtopic known as projectile motion. So I believe most of you have not really heard of projectile motion before, but don't worry, this video I'm going to try my very best to sort it out for you. So all you need to do is listen carefully, pay attention, and if you need to pause the video, think about it, or you can even rewind to listen again to the video. So this video is totally yours, so you learn it at your own pace. Okay, so projectile motion is also known as 2D motion, two-dimensional motion. Why? Because it is essentially made out of two dimensions, which are the x dimensions and the y dimensions. So we're going to explore more in these two dimensions, which are very important for projectile motion. But what does a projectile motion look like? What is it actually? So projectile motion is a motion experienced by an object projected into the air, and when it moves in the air, it actually moves along a curved path. Why? Because it's under the influence of gravity only. Gravity only is very important, because what does it mean? It means that air resistance is negligible. So actually, you've seen projectile motion in your daily life. It's just that you don't realize that this kind of motion is known as projectile motion. So one of the examples is when you kick a ball into the air and the ball will move in a curved pathway like this. So why is it move in a curved pathway like this? So we're going to dissect it. We're going to explore more into the path that the ball experiences at any point of air. So when the ball is kicked up into the air, can you see that the ball path is essentially made out of two dimensions? They are the x dimension and the y dimension. So we're going to look at how this x dimension, this x components and y components contribute to the projectile motions of the ball. So when the ball is projected up into the air, at any point of time, you can see that direction of the velocity, which is denoted by the arrow here, is always tangential to the path of the curve. And this path and this velocity here can be resolved into x component and y component. This x component is not affected by gravity, which means the acceleration along the x component is always zero. Please remember this. This is very important. Okay? And for y component, it is always affected by gravity, which is negative 9.81 meter per square. Why is it a negative here? Because this negative sign shows that the acceleration is always downward. Have you seen any acceleration, gravitational acceleration pointing upward? Have you seen anything, any object that is accelerated upward into the sky? No, right? Why? Because the acceleration due to gravity is always pointing downward. Okay, so that's why we have a negative sign to show that it's pointing downward. So please remember these two. These two are actually the heartbeat of the whole projectile motion. Once you understand this, the rest of the projectile motion will be very easy to understand. Alright? So as the ball continues to travel into the air upward, you can see that due to the x component not affected by the gravity, so your x component, there is no acceleration along x component. So still remember in the earlier subtopic, when there is no acceleration. Acceleration equals to 0. What does it tell you about its velocity? The velocity remains the same. Okay, so the velocity along x component remains the same because the acceleration is 0 along x component. But what about for y component? Because of the effect by gravitational acceleration, the y component, the velocity along the y component will decrease. So you can see that the y component, the magnitude will decrease until it reach maximum height. At maximum height, you can see that there's no more y component, and there's only x component, which remains the same as your initial x component. Because why? Again, it is not affected by gravity. Acceleration is 0. So when the ball then projects downwards, your y component, magnitude and direction remains the same, but your x component, the magnitude and the direction remains the same, but for y component, the magnitude started to increase due to the gravitational influence, because it is now pointing downwards in the same direction as your gravitational acceleration. So as the ball is now moving downward, the y component increases until it reaches the ground with the maximum magnitude for your y component. But the x component remains the same throughout the whole projectile motion. Okay? So this is your final velocity. Okay, so this is a very important chart for you. If you understand this, the rest is very easy for you. Okay, so for your x component, you must remember that what governs the whole projectile motion is actually its acceleration. So you always have to think about its acceleration in x component and its acceleration in y component. So for x component, as I said earlier, the acceleration is always 0 because there is no gravitational influence along the x component. And because acceleration is 0, that's why your velocity is always constant throughout the whole projectile motion along x component. So your initial, which means that your initial velocity along x component will always equal to the final velocity along the x component. And if you substitute acceleration equals to 0 into this formula here, into the kinematic equation, Sx equals to uxt plus half az. So because acceleration equals to 0, so this part here would be 0 as well. So you are left with just Sx equals to uxt. So this is what you need to know for x component, which is essentially governed by ax equals to 0. So for your y component, you always have to remember that your y component is influenced by the gravitational acceleration, okay, by gravitational force. So that's why the gravitational acceleration along y component is always negative 9.81 meter per second squared. Okay, so with this information in your head, you then can substitute this acceleration and put it into these 4 kinematics equations, and you can use it as you see appropriate. Okay, so again, I stress these 2 acceleration along the x component and acceleration along y component is the only thing, is the heartbeat of projectile motion. So once you get this, you can work out the rest of it yourself. Okay? Projectile motion can look differently in different scenarios. So here I'm going to present to you 3 different scenarios for projectile motion. So the first case would be a projectile motion from ground to ground, okay, where the ball is projected from the ground into the air and reach a maximum height before it falls back down to the ground again. So this is sort of like a full projectile motion. Okay, so let us analyze it from the very beginning of the projectile motion, where the ball is being projected upward. So when the ball is being projected upward, there is an initial velocity u, which is tangential to the path of the motion. And this u is at an angle theta above the positive x-axis. So as we can see here, because there is an angle, it means that this u, this initial velocity, actually consists of x component and y component. So what you need is to resolve it into x component. How do you resolve it? Remember? If you have forgotten, please revise your vector resolution and also your trigonometry. Okay? You have to remember this for life, at least for matriculation here, in order for you to survive, right? So what is the x component for u? Ux equals to u cos theta. Why is it a cos theta? Because your x component is adjacent to your theta. Okay. What about your y component? Uy equals to u sine theta. Why is it a sine theta? Because your y component is opposite theta. Alright? Okay, now let's go all the way to the other end where the ball reached the ground. Okay, so where the ball reached the ground, what happened to its velocity, its final velocity? Yes, just before the ball reached the ground, the ball actually has a final velocity. Please do not think that when the ball reached the ground, there is no velocity because the ball stopped on the ground. No, okay? What this velocity refers to is the velocity just before the ball reached the ground. Okay, in fact, the velocity is maximum. Okay, and it is tangential to the path of the projectile motion as well, at an angle theta below the positive x-axis. So again, this final velocity can be resolved into x component, whereby Vx equals to v cos theta. And still remember earlier on, what do we learn about the x component? Yeah, acceleration, it's always zero because there is no gravitational influence along the x component, which also means that your velocity is always constant, which also means that your Vx equals to your Ux here. Okay, please remember this. And what about your y component? Vy equals to v sine theta. Okay, so the first thing you need to do is always to resolve your velocities first. Okay, then after that, we are going to start collecting and generating information. Okay, so let's start with when the ball reached the ground. So think about it. When the ball reached the ground, what information can you know about the ball? Yeah, the two most obvious information you can generate is your velocity. Your Vx equals to Ux equals to v cos theta, just as you have resolved here. Okay, and Vy equals to negative v sine theta. What is the negative doing there? Yeah, it is because your velocity Vy is pointing downward. Okay? Okay, what else? What else? Apart from velocity, what can you know about the ball when the ball reached the ground? What about its displacement? Okay. So what is actually a displacement? So remember, it is the shortest distance between the initial position and the final position. Okay, and this displacement can also be divided into x component and y component. Okay, so let us look at the x component of your displacement. So what is the x component of your displacement? So this is your initial position. This is your final position. So along x component, what is the shortest distance? Yeah, it's this one here, which is also known as range R. So your Sx equals to R. And if you can recall from earlier on, if your acceleration equals to 0 and you substitute that acceleration equals to 0 into this equation, Sx equals to uxt plus half at squared, what you get? You get Sx equals to uxt only. Okay, so please remember this. Okay, what about along y component? What is your displacement? Again, this is your initial position. This is final position. So what is the shortest distance between these two positions along y component? Y component. Is there any difference? No. There is no difference along y component between the initial and the final position, right? So your Sy equals to 0 because they are all lying on the ground. Initially, the ball is on the ground. Finally, the ball is also on the ground. So there is no difference along in terms of y component. So Sy equals to 0. Okay, so these are the information that you need to know, okay, when the object reaches the ground. And of course, you can't forget time of flight. So what does flight mean? Flight means when the object is in the air. So what is the time when the object is in the air? So it's essentially, time of flight means that the time when the ball travels from here to here in the air. Okay, so which is just a t lah, the time taken. Alright? Okay, so what about when the ball reaches maximum height? So this point here is a point, it's a maximum point, maximum height of the ball along the whole projectile motion. Okay, and the distance, maximum height from the ground, is known as maximum height lah. Okay, and it's denoted by this symbol here, h. So now generate information of the ball at maximum height. What do you know about the ball at maximum height? So first of all, you can know about the displacement along x component. So again, this is your initial position. This is your final position. So what is the shortest distance along x component? Yeah, it's this distance here, which is half of your entire range. Okay. Okay. What about Sy? Displacement along y component. This is your initial position. This is your final position. What about the difference, the displacement along y component? It's this one here, right? Which is h. So your Sy is h. Okay? And it is a positive y because the final position is above the initial position. The ball is actually going up. Okay, so that's why Sy is a positive value. Okay, what else? A very important information that you must automatically know at maximum height. Velocity. Okay, so at maximum height, you must know that Vy, the velocity along y component, is always 0. Refer back to the vector diagram of the football that I've shown you earlier on. Okay, at maximum height, your Vy is 0. Okay, you only have x component, which is the same, okay, along the entire projectile motion. And what about the time? Time between the initial position to the maximum height. It is half of the entire projectile motion. Time taken for the entire projectile motion. It is half of time of flight. Okay? Case 2, second case. So second case is where the projectile motion is where the ball is projected from a certain height into the air, and it will fall back to the ground. It will fall to the ground. So this is what the second projectile motion looks like. Okay, so again, let's figure out what happened to the ball initially here. So initially, when the ball is being projected from a certain height h, what happened to the velocity, initial velocity? What is the direction? Tangential to the path. Okay, so tangential to the path. So meaning that, is there any y component initially? No, there is no y component. Uy equals to 0. You only have ux. Okay, because the ball is being projected horizontally from a certain height. Okay. Okay, what about when the ball reached the ground? Of course, again, it will have a final velocity which is tangential to the path as well at an angle theta below the positive x-axis. So resolve this velocity, you'll get Vx equals to E cos theta, also equals to Ux. Okay, which is the same. This one, final velocity x component is always the same. Okay, and then Vy equals to V sine theta. So when the object reached the ground, what are the informations that you can generate? Yep, your velocity, Vx equals to Ux equals to V cos theta, and Vy equals to negative V sine theta. Okay, what else? Please recall from the first case earlier on. What can you know? Displacement. Yeah, your displacement. So what is your displacement along x-axis? It is your range here, where initially your ball is here, and finally your ball is here. So what is the displacement along x-axis? It equals to your range r. Okay, so Sx equals to r also equals to uxt. What about your y component or your displacement? So y component, initially your ball is here, finally your ball is here. So what is your displacement along y component? Initially, finally, along y component. Yeah, it's actually your height here. Initially your ball is here, finally your ball is there, and then your sy is this height. Okay, but there's a negative here. What is the negative doing there? Yeah, it shows that the ball is going downwards. The final position of the ball is below the initial position of the ball. The ball is going downwards. The displacement of the ball is pointing down. That's why there's a negative h. Okay, and of course, time of flight is the time taken for the ball to travel from this position to this position. Okay. Okay, so now let's look at the third case. So the third case is where the ball is being projected from a certain height upwards into the air, and then it will fall to the ground. Okay, so now let's look at what happened to the ball initially. So as usual, please figure out what's the direction of your initial velocity, which is tangential to the path at an angle theta above the positive x-axis. So once again, resolve your u into x component. Ux equals to u cos theta. And also y component, u sin theta. Okay? Okay, so what about when the ball reaches the ground? What is the direction of your final velocity? Again, tangential to the path, which is at an angle alpha below the positive x-axis. So once again, resolve your final velocity into x component. Vx equals to v cos alpha, also equals to ux. Recall y? I leave the answer to you to figure out. Y is Vx equals to Ux. Okay, I hope you know the answer. And your Vy equals to V sine alpha. Okay, so always remember to resolve your vectors before you start gathering information. Okay, so next let's collect information starting from when the ball reached the ground. So when the ball reached the ground, what information can you collect? Can you try? Okay, you can pause the video and try collecting information on your own. Okay, so what do you get? Do you have velocity Vx equals to Ux equals to V cos alpha and Vy equals to negative V sine alpha? I hope you get these two obvious information. Okay? Okay, what else? What else did you get? What about the displacement? Do you get the displacement along the x component? And what do you call that displacement specifically? Yeah, it is the range here. Okay, your initial position is here, and this is your final position. So along x component, this is your range. Okay, so you have Fx equals to R, also equals to Uxt. Okay, what about your y component? What do you get the y component for your displacement? Initial position is here, final position is here, and the shortest distance between these 2 points is the height here, right? Do you get that? So you have Sy equals to negative h. And what does this negative mean? It means that the ball is, the displacement of the ball is pointing downward, okay? Because the final position is below the initial position, okay? Please remember that. And finally, what do you get? You will have time of flight equals to a certain time, t. And this time of flight is the time taken for the ball to travel from this position here all the way to the final, to the maximum height and to the ground. Okay, so that is the time of flight. So do you get all this information correct on your own? Okay, what about when the ball is at maximum height? What information can you gather? Can you try again? Right, so what do you get? What is the most obvious and important information that you must have? Do you have this? Vy equals to 0? Yes, that is what you must have. Whenever you think about maximum height, you must have Vy equals to 0 naturally flowing out from your head. Okay? And what else do you know? What about your displacement? y component, displacement along the y component. So this is your initial position, and this is your final position at the maximum height. So what is your SY? Initial, final. So your SY is, your H here. This is your SY. Okay? So SY equals to positive H because your ball is, the final position, the maximum height, is above the initial position of your ball. So the ball is actually going up to the maximum height. Okay? So, yep, that's for projectile motion. So I hope that you understand better what projectile motion is and are able to apply everything that you have learned in this video. So I'll see you soon. I'll see you again in the next video. Bye.